Hi, my name is Nicholas Koonsman, and today I will be discussing my senior project regarding reducing the manufacturing learning curve at pet doors. So, first off on the agenda is a background about pet doors and what they do, the problem statement, some of the issues that come up in the manufacturing process, as well as the objectives and goals I plan to accomplish at the end of the senior project. After that, I will go into some of my literature reviews as to reference some uh, materials and other things people have done outside of the facility. Next, I'll move on to the design and methodology of the process. And in the end, the expected results and deliverables that I will be giving to the client. So, first off, is petdoors.com. They're a small e commerce business, around 15 employees, and this varies a lot because they are located in San Luis Obispo. They hire more or less 5 college students at a time, and that varies a lot because students are constantly graduating or moving to different jobs, and then they're rehiring new people to fill those positions. On top of that, they sell and manufacture top of the line pet doors. So they are of the utmost quality, very expensive, and so the customers do have a very high expectation when they pay for the pet door. And because of this, they do have a low volume production cycle with a medium amount of variation. Uh, Basically, three main product family groups with some variation, but there are some custom orders that need to be accommodated as well. So, moving on to the problem statement. PetDoors.com serves to produce the highest quality pet doors on the market. Due to these high standards, quality is of the utmost importance, but this can be difficult due to the high complexity of the production process. Training new employees to meet these high standards and learn the complex process results in a high learning curve and the throughput of lower quality products during the training cycle. Now, as you can tell, this is a problem because, like I said before, there's a lot of variation as to college students that come in and out or just new hires as the company expands. So, meeting the production needs means you have to increase how many people are working in the manufacturing section. And in order to accommodate this, you need to make sure that they're meeting the quality so that customers are not receiving products that don't represent the company well. And because the process is long and complex, there's a lot of different moving parts and, like I said, a lot of variation. We want to make sure that not only are they getting the quality that they deserve as the customers, but the production cycle and the throughput of a new trainee is not significantly less than that of someone that has worked there for a long time. So moving on to the objectives. The first objective is to reduce the learning curve and the training time, which will then in turn reduce training costs and increase production for these new hires. In addition to this, we would like to reduce the overall product quality variation because the first step in increasing quality is reducing the variance within the product and manufacturing process. And once we are able to narrow that down, it's more easy to increase the quality as necessary. So, like I said, meeting these objectives will make new employees more effective, reduce labor costs, and standardize product quality throughput. So, moving on to some literature reviews, I'll be listing 3 here, but there will be many more documented in the final senior project. Starting off with the first article was a production quality control system is in action. So this is based off a system of standards that was developed by the Mitishiki engineering plant. This is out in Japan, and the idea behind this was that there are inspection cycles, but not just someone that looks at it and says, okay, it's good or not. They actually have a written form that needs to be checked off in which standards are met, and someone would have to sign off on that, taking on responsibility for the fact that those products are of the quality standards that they're said to represent. And from this, implementing the system, you can increase product quality, reduce the quality variation. Like I said before, that's one of the first things you need to do in order to increase quality. It does implement an assembly line process because you have multiple stops in which different people are checking off and signing off on the forms, making sure that everyone is in line doing their job, and taking on the responsibility during the manufacturing process. So if something does come up, go wrong, quality is not meeting the standards, you are able to find out where it's going wrong, and not necessarily enforce punishment, but try and solve the problem with, if it's a certain manufacturer during a certain process, locate where exactly the issues are arising. The next of the literature reviews is called A Method to Determine Optimal Simulator Training Time, examining performance improvement across the learning curve. So, in this article, it was all about training optimization, but specifically simulator training time, which has to do with training someone in a field or area, specifically manufacturing, that increases the production process or their throughput, their quality when they start in the actual workforce or assembly line. And by doing this, you go backwards and give them simulator training, which is referred to as training time with no product throughput. So basically, whether it be watching videos, they talked about some VR systems that you could actually use to try and learn how to create the product. But you're trying to reduce that period where they're on the height of the learning curve, where there's a lot of time and quality and just things being learned by them, where it's easy to make mistakes. Have them do that all in a simulation where they're not actually putting out products, and so they can learn the quality standards for when they start. Now, while this does take more time in the initial training process sometimes, it does reduce the amount of training from other people in the workforce or assembly line. So that would decrease the overall time taken from them, but it also reduces the quality variation or loss of control when they're initially introduced into the cycle because they do have some background knowledge to go off of. So this training optimization aims to reduce the training time or optimize the training time without throughput. Overall, reduce training costs because you're not pulling other more high-paid or well-knowledge workers from the work area. Increase their starting performing index, so they're able to perform at a higher rate and of higher quality, and able to put through products that would meet the standards that are needed. Last of the literature reviews is using yield models to accelerate learning curve progress. Now, this aims to improve the learning process by increasing quality control through the implementation of yield application models. Now, in this article, they gave some specific examples. Sematech was one that was introduced into a current system, and I know there's a bunch of systems or applications that can be used to do this, but they are high-tech systems that are used to detect manufacturing defects or flaws. And now, this is a much more expensive route to go through. There's a lot of startup costs in order to implement it. Usually it's in a very mechanized or automated system, so it's easy to get data specifically from those. But the idea behind it is you have cameras or systems put into place that are able to detect exactly when something does not meet the standards, whether it be putting it through some sort of quality test, inspection, or just during the actual production cycle, having cameras take pictures and analyzed in the database or in the program itself, the software, and being able to detect defects that way, so it takes some of the pressure off of the workers, and you can in turn have less skilled labor needed because it would, like I said, take out some of the pressure off the employees, and they wouldn't need to know exactly what to look for because they could just have something tell them whether the standards are met or not. This data is collected and can later on be analyzed by an industrial engineer or someone else in the workplace to find out exactly where the defects are taking place or what processes are slowing them down, bottlenecks, things like that, because there's so much data available. And this leads to further process improvement, higher quality, quality control, and then in turn, like I said before, reduced need for skilled labor, and usually that increases production cycle time and throughput. Now, for the design of my senior project, there are basically two main processes I want to tackle. Process improvement is the first one, and then next is the facility redesign, which kind of has to tie in with that, but I'll get into that in a second. So in order to facilitate the process improvement, I'm going to use flow diagram, work processing diagrams, some line balancing to find out where exactly the bottlenecks are, do an inventory and work in progress analysis, as well as set up a standard operating procedures. These will all coincide and work together in order to ideally reduce the product or the process cycle or process time, manufacturing cycle time, and help facilitate a faster throughput in the workplace. In addition to this, comes with a facility redesign because the facility is not it was not designed by industrial engineers or it was just kind of set up based on what they felt was needed. I'm going to go back and analyze some of it, see exactly where travel time can be reduced and things like that. So for this, I'm going to be using some 5S systems, doing some ergonomic considerations in terms of what needs to be where and reach requirements, things like that. Using a spaghetti chart, once again, like I said, to reduce travel time and try and make sure that the flow of the system works very well and people don't need to jump around so much. And last is help with inventory management using the facility redesign, implementing some kind of Kanban system so people know exactly when and what needs to be replenished at what times. Now for the expected results and deliverables, some of the deliverables I'll be giving is a new training process and procedure. This will be a list that each new trainee should be taken through, what order it should be done so they can learn the quality standards necessary as well as be more familiar with the process before they're actually boxing the final product. This will result in a reduction in training time as well as improved quality. Next, moving on, would be the workbench redesign and standardization. Currently, there are many workbenches in which the products are assembled, and each one varies based on what builder is there. But like I said, because of part-time shifts, scheduling, all that, there are basically only 2 builders that work there full-time that really have their own set station. So everyone else is jumping around, moving different benches depending on when they start or how many people are working at the same time. So in order to make sure that people don't get confused and aren't reducing their increasing manufacturing time because they're working at a different bench, we're going to standardize it and give some more flexibility as to where people can work because all areas will be the same and it will be easy for people to find specific things and know exactly where they are. Moving on would be the manufacturing facility redesign. Like I said, the goal of this is to reduce travel time and lead times, introduce a Kanban system. Uh, Ideally, we'd like to set up areas in which specific processes are done and then a final assemble area where everything can be put back together or assembled and packaged. This will reduce travel time because current processes take people all over the workplace, and so travel time is much higher. Reducing the travel time will then, in turn, decrease lead time because they will spend less time traveling during the process and more time just focusing on the actual production cycle. Next would be the Kanban system, which would help with the inventory management because there are certain parts and because it's an assembly line, we're going to try to use a pull, not push system so we know exactly what things need to be refilled and not wasting time making parts that are just going to sit around for a while and potentially get damaged and then have to be scrapped for metal or whatever reason because they've not been handled properly because they have either been overstocked or just sitting for too long and no one's been able to find exactly what they need. This moves into the storage design, which help controls the materials handling process. Right now, there's no set process as to how extra or pieces of random metal are stored so that they can be used further. And so having a set system for exactly how the materials can be handled and where they should go specifically, marking these areas and making sure everything has a place will play a huge role in trying to reduce the amount of scrap and increase the product quality so people aren't using parts that they think are actually of quality that someone else has set aside because it's been defective in some way. Now, that is it for the presentation. I'd love to get your feedback. Please let me know if there's anything you'd like to add, change, or simply talk about more areas that you think have more influence, place to focus on. And so thank you for listening, and I hope to speak with you soon. Thank you.